Okay guys, today we are going to prove this theorem 1.1.5, which states that the set of integer z has only one subset that satisfies trichotomy law, which is a set of natural number n. Okay, we've known that according to trichotomy law, there is a subset, let's say a set of natural number satisfy trichotomy law. Okay, which is this one, right? These three laws. Okay, and my question is there any subset except a set of natural number satisfying trichotomy law? Okay, but according to this theorem, there is only one set. That set is a set of natural number. All right, let's prove it. Let's start with proof. Let's prove it. I gotta pick a subset of integer. So we're gonna assume that. I'm going to assume that S is a subset of a set of integer, and S must satisfy trichotomy law. Okay, S satisfy trichotomy law. So what do we have when you satisfy trichotomy law? So we gotta have, the first one is 0 is not included in set S. Okay, the second one is for any two element in set S, the sum of two elements is included in set S, and the product of these two AB is in set S. And the third one, when you pick one of integer, or every integer can be in set S, or it can be 0, or it can be negative integer in set S, right? That's what we have right here. Okay, so right now S satisfies trichotomy law, and we want to show that set S must be a set of natural number. So typically if you want to show that set A equal to set B, we have to show that A must be a subset of B and B must be a subset of A. Okay, but the difficulties of this one and this one may not the same. This one may be harder than this one, or this one may be harder than this one. So for this case, if you want to show that S is equal to a set of natural number, I gotta have to show that S is a subset of natural number, and a set of natural number is a subset of S. If I start with this, S is a subset of a subset of natural number, I think this one is quite difficult, because if you try to let a natural number, let n in set S, and we don't know what the set S look like, right? We just know that set S is just satisfy trichotomy law. Okay, so this in this way is quite difficult. So I want to start from here. I want to show that a set of natural number is a subset of S. I want to start with this first. So I got to show that the set of natural number is a subset of S. Okay. Now what can we do? I gonna let n, okay, let n be an element in the set of natural number. So s must be a positive integer right now. And I want to show that n must be in set S. But we know that S satisfy trichotomy law. These number 1, 2, and 3 here. So let's start to show that. Let's start to show that or claim that 1 is in set S first. Why do you do that? If I can show that 1 is in set S, right? I can have 1 plus 1 in set S, which is 2, because S satisfies trichotomy law and the second law of trichotomy law. If I have 1 and 2, I can have 3, which is 1 plus 2, right? And if I want to have number 4, I can use 3 in set S and plus 1, which is 4 in set S. And 5 equal to 2 plus 3, and so on. Okay, and so on till any integer, any positive integer. So now, let's start with this. Let's claim that S is in the set S. And we know that number 1 is an integer. And S satisfies trichotomy law. Alright, what happened next? The third law here. So from the third law, what do we have? The third law implies that 1 is in S, or minus 1 is in S, right? Okay, or minus 1 is in S. That's what happened. You can have 1 in S or minus 1 in S. Minus 1 in S. I just want to have 1 in just S. I think that I gotta prove that minus 1 must not be in set S. So I gotta use the proof by contradiction from now. Okay? So I have to suppose that. Let's do the proof by contradiction. Suppose that minus 1 is in set S. Okay. Now minus 1 is in set S. And now, since minus 1 is in set S and S satisfy trichotomy law. Okay? And S satisfy trichotomy law. So what do we have? I gotta use the second law. Okay? The second law. What does it imply? The second law right here, I want to start with multiplication. When minus 1 is in set S, you can have minus 1 times minus 1, which is 1, and is included in set S. And once you have 1 and minus 1 in set S, what can we have? Okay? And then minus 1 plus 1 is 0. And the sum of element in set S must be included in set S, right? Because S satisfies trichotomy law, the second law. Like now, 0 is in set S. But I say that S satisfies trichotomy law, but 0 is in set S. This is a contradiction to number 1. 0 must not be in set S. Okay, so what can we do with this? Right? But I gotta say that 0, which is minus 1 plus 1 in set S, is a contradiction. A contradiction to number 1. in Trichotomy Law. Okay, which state that 0 is not in ZS. Okay, so this means that what we suppose here, -1 in ZS, is false, right? So -1 in ZS must be false. Therefore, okay, therefore -1 cannot be in ZS, and hence right now 1 is in ZS. Okay, this means that this statement is now false. What we have right now is just 1 is in ZS. Okay, great. 1 is in ZS. What can we do? If 1 is in ZS, we will use trichotomy law. So since 1 is in ZS and ZS satisfies trichotomy law. Okay, the second one, right? The second one, the sum of two elements in S must be included in set S. So the second law implies that. It implies that 2, which is 1 plus 1, is in set S. Once you have 1 and 2, you can have number 3, because 3 is 1 plus 2 in set S. You can have number 4 because you have 1 plus 3 or 2 plus 2. In this case, I'm going to use 1 plus 3, okay, which is in set S. Or you can have number 5, which is 2 plus 3. And all the way and so on. You have 6, 7, all the way to n, which is 1 plus 1 here, okay? Which is 1 plus 1 plus 1 plus 1 all the way to 1 plus 1. Why? Because 2 is 1 plus 1 is in set S, okay? And they are n terms of 1. So n must be in set S. So we have shown that when you let n to be in the set of natural number, and it leads to n in the set S. In set S, what does it mean by this? Since n is in set in a set of natural number leads to n in set S. Okay, a set of natural number is a subset of S. Okay, good. We have n is a subset of S. What does it mean by this? Since n, a set of natural number, is a set of S, it means that set of n equal to set S, or set S different set of natural number, because n is a subset of S. When you exclude all the elements in a set of natural number, there must be an element in set S, so it's not empty. Okay, it's something like this. Let me draw a picture. A set of natural number is inside this circle, and this circle is set S. As different n, for S different n, this set operation, meaning that you have to exclude all the elements in the set of natural number. When it's not empty set, this means that you need to have some element in set S. Okay? So, but I want to have a set of natural number equal to set S. So let's move on and continue. I want to claim that a set of natural number. Set S is a set of natural number. Okay, what can we do with this? I want to prove that set S different n, which is not every set, is false. Okay, but I use a proof by a contradiction, so I have to suppose that. So I have to suppose that set of S different set of integer is not empty set. Okay, then what do we have here? Then there exists, okay, there exists set of X, sorry, and an element X, let's say X is in this set. Okay, so X may be somewhere here, but it's not in N, right? Okay, somewhere here. So what does it mean by this? When X is in S different N. Okay, this means that X is in set S, but X is not in the set of natural number. Okay, so since X is not in set S, okay, and we know that set S must be a subset of integer. So what does it mean by this? This means that X must be integer, but X is not a positive integer. What does it mean by this? This means that X is negative integer. Okay? And it's not 0, right? So it cannot be 0 and minus X is in set of natural number, because this implies that X is a negative integer. Okay, so what can we do next? Since we have N is a subset of S, okay, set of natural number is a subset of S, and minus X is in a set of natural number. This means that minus X is in a set of S. Okay, now what do we have here? We have X in set S and minus X in set S. We will use trichotomy law. Okay, we will use trichotomy law. So since 0 X is in set X, minus X is in set S, and S satisfy trichotomy law. Okay, so what does it mean by this? So the second law, okay, what does it imply? It implies that we can have 0, right? Because why? Because we have X plus minus X equals 0, and it must be in set S. So if you have X minus N minus X in set S and S satisfies trichotomy law, the sum of X and minus X is in set S, but the sum of X and minus X is 0. and is contradicted to the fact that x cannot be 0. Why? Because x is satisfy trichotomy law. Okay, so we have x not equal to 0 right here. So we have a contradiction, okay, which is a contradiction to number 1 in trichotomy law. In trichotomy law, which state that 0 cannot be in set S. Hence, what we suppose right here, which is S different set of natural number is not empty set, is false. Okay, S is not empty set is false. Okay, therefore it must be empty set. Okay, S different n must be empty set. One it is empty, this means that set S equal to a set of natural number. Okay, this means that set S and n have the same circle in the Venn diagram. It's exactly the same. They have equal number of elements. Okay, so this shows that only one subset of integer that satisfy trichotomy law is a set of natural number. So if you let S, okay, to be a subset of integer, okay, and S satisfies trichotomy law, it implies that set S must be a set of natural number. Okay, so that's it for today. Okay, and see you in the next video.